Good afternoon, everyone. This is lecture number 20 and it's on differential amplifier E512 CMOS analog IC, right? So few things are there. One is called single-ended. Single-ended is the one where single input and single output is there. Whereas pseudo differential are the one where two inputs are there but single output and there is no dependency between two networks. Whereas in the differential, actually two inputs are there, one output. However, there is dependency into particular networks. I'm also expecting that this is old one. I believe everyone knows this, right? And this is called fully differential, where two inputs and two outputs, and the most important part is they have to be 180-degree phase shifted to each other. So why do we prefer differential over single-ended configuration? The only thing is single-ended having all harmonics, even some common mode noise that needs to be removed. So that is what the main purpose of the differential. This is one of the example where I am showing that if input is differential, where this is governed by this linear equation y equal to mx plus c. This is for the ideal condition, but in reality that's not true. The true situation is as follows, where y is actually depending on so many higher order polynomials, right, where m1 m2 m3 and m4 and all these are depending on the slope, right, and their units are different, where c is the initial condition, or it's also, you can say that it's a DC value, right? So when we are taking this in terms of V out, one is Y1 and one is Y2, and X is nothing but an input, Y is output, and C is the input in a case. Whatever situation I kept it over here does not have any value of C. But if you look at both the side, here plus V in is going and here minus V in is going. This we are doing for some reason, right? That is called differential. Differential is all about 180-degree phase shifted to each other, right? So if plus V in and minus V in are there, what we need to do, if y1 is equal to m1 x1 plus m2 x2 square plus, actually it has to be x1 square x1 cube and so on and so forth, and same way if it is x2 cube and so on and so forth. So if you are doing this, two side to y1 and y2 are available. They are governing with this non-linear equation because transistor is a non-linear device. And if you are doing this, if you remember, I am talking about differential circuit. Differential is nothing but when you are taking 180-degree phase shifted input output depending on whatever you are doing, right, at input side or at the output side, right? So if you are doing this, then it becomes differential. So if y1 and y2 are the two outputs, then to take them differentially with each other, actually they will be also 180-degree phase shifted to each other, as you are giving 180-degree phase shifted input. So if you are looking into this y1 and y2, you have to subtract it. So what's going to happen in that case? When you are subtracting both of them, and if x1, which was V in, and x2, which is minus V in, if you keep it here, what's going to happen? That all, so the DC value is removed, that goes to 0. Then all odd harmonics will be here, right? Whereas even harmonics will be going to 0 again. So that is what's happening over here. But the most important thing which is happening over here is actually the input gets double when you are taking the differential, and output is also getting double. So the ratio remains same. Gain does not change. However, the input and output relation wise, if you are looking into that, your actually the swing is getting reduced if you are looking at the differential one. Okay. So it's 2m1, 2m3, so on and so forth. All these are different slopes of the input output characteristic. So here you can see its even harmonics goes to 0, and it gives better noise immunity which is happening at DC. So anything is at DC, it's going to become 0, right? So that is what happening over here. So this is known, right? That means this is known, or okay, if it is not known, remember it, right? And do not forget this. This is okay. So these are some of the circuits which we need to convert it to pseudo differential networks. Okay. Please try. Let me know. Convert it to pseudo differential. You know how to make pseudo differential. Okay. What is differential? So when you are doing this, you need to do something with the circuit also. If it is single-ended, do you agree with this one? This is single-ended. All these circuits are single-ended, single input, single output. If you want to make it two inputs and two outputs, how to adjust two inputs over here? So the simple thing is, same circuit, copy that. Same circuit, copy, keep it over here. Same circuit. Here we have given V in. Here you give minus V in. So then this is differential. Note that both the circuit are not disturbing each other. You see? So output of V out plus is not a function of V out minus. They are independent. That's why it's a pseudo differential. It's not actually differential, but it's pseudo differential. Right. So let's make the next circuit.
So the resistance R2 is
very small. Let's consider this one as a new circuit. Conceptual, I was explaining. If you know, then please make the second circuit. It should not take much time, right? So this is simple one. It's a copy only. Just another one will be minus V. Same for this one also. Everything will be same, right? Or DC will not change, right? So this becomes minus V M1, M2, M3. You are able to do that. What's the name? Abhishek or
Aditya.
Aditya. Yeah. Aditya, you got all these answers? Okay, so this is the output, right? Let's go to the next thing. So it's a copy thing. Now it's all about, so if one balanced network has been given to you, one balanced network, just we have given one like this one. If one balanced network has been given to you, the copy of second one, you are going to keep it over here. It's a carbon copy. Control C, Control V. It's the same thing, both sides. And if I am applying one side plus V and another side something else. By the way, I forgot to Getting very important thing over here. So when you are, what is common mode by the way? What is common mode? What is common mode? What is common mode? What is common mode?
It is common both the
Hmm. Okay, so here there might be DC, sometimes it might be AC also, right? So both same, then it's common mode. So in that case also, this common mode is going to be removed, right? If both the networks same thing is going, then it's removed. So we should not say only that it's removing the better noise immunity, but another word for this one is there is common mode noise is removed. Whatever available in common mode noise, that's getting removed, becomes zero, right? Okay. Any problem in this, Narmit or Abhishek? What about at the back? Srishti? Vishal? Where is Vishal? Okay. I used to see here only. Anyway, so if there are two identical balanced network, as I told you, like it might have transistors, it might have resistor, capacitor, inductor, whatever it is there, same carbon copy, I kept it over here. If I am doing so, and if I am connecting both of them through some voltage sources, that might be uh, ideal one, or independent sources coming from maybe some function generator or anywhere. So different situations are there. Let's go with the situation when do I have kept? So there is a situation if one side I am connecting. Okay, do not go with these notations, they are actually not correct. Okay, so what if I am giving here plus V and I am giving here minus V, means differential, what's going to happen? Can you comment on Vx, Vy, Vz, Vw, which are connected between these two balanced networks? What will happen if Vx, Vy, Vz, Vy, like they are connected? Can you comment on Vx, Vy, Vz, Vw?
Zero.
What do you say? So they have to be zero. Why? Why do you think it's zero?
For same network, we are applying plus B input here and minus B there.
Hmm.
So that output will be superimposed to each other. So that was Vx, Vy, Vz.
Or you can say that the current going from this network is actually, this is minus, so it has to be going in if it is going out. So at this particular node, this is only possible when there is no branch going down, right? So you can say that this is Vx, Vy, Vz, all these things are having they are actually, you can consider them as virtual ground, right? So it is not that, however you can consider that as virtual ground because current flowing through that one is going other side, right? This is similar what we have studied for creating a zero, right? So this is true for all Vx, Vy, Vz and Vw if both the networks are identical. If you are giving one side plus V and one side minus V, what if we are giving both V? No answer from Santosh.
The same part.
No answer from Santosh. You have studied mixed signal with me, right? And then you are answering here. If both are plus V, then Yugal, what do you think?
Voltage double.
Why double?
Because same potential is applied from both the sides, so it will be 2V.
By how it becomes 2V?
Same potential. Because two voltages are acting on the same potential as well.
So I can say that in terms of current. Look, I can't say on voltage. I can't comment on voltage. But if I keep something over here, in terms of ammeter.
Then they will be.
So then the current has to be double. The current which was going from here and current going from here. Voltage is depending on what you are keeping as resistance, right? So then I can do that. By the way, I need to keep resistor, right? Not only this one, right? Otherwise, it's considered as actually, across voltage I am checking, right? So this way, if I am doing, the current becomes double. In the previous situation, when it was plus V and minus V, this particular Vx, Vy, Vz, Vw all goes to 0, right? Virtually. They are not there. You have to see that they are 0. They are not actually 0. They are not 0 in reality. But this is only happening if you are going to give the differential signal. So there are two situations, when one is the differential situation and one is the common mode situation, because those two are happening in your circuit. So I am going to treat both of them separately. One is the common mode and one is the differential. So in differential, I am going to give plus V and minus V. In common mode, I am going to give both sides plus V, and then I am going to check. It might be AC, it might be DC. It doesn't matter, right? So differential can also be plus minus. Okay. So now, by the way, I am following same book, Behzad Razavi. Okay, so all the slides are copied from Behzad Razavi's book, right? Or whatever I'm taking reference, it's Behzad Razavi. Okay, so if single-ended is there, differential, I know that it's a carbon copy, both sides same. So if I am giving V in plus here, other side is actually minus of that. It's a differential. So what is the advantage of differential, Dharmesh?
So better noise immunity and no harmony.
No harmonics. Harmonics will be there.
Oh.
You can't get rid of harmonics.
Even
Harmonics. So even harmonics are not there, and common mode is also you are getting the reduce, or any problem is coming, then you are going to do this, right? Okay. There is sometimes, single-ended has some situation I am giving. This situation is very common when you are going to laboratory, and let's assume that you have one amplifier, and on one side you are saying you are expected to see, actually it's a common source, so it has to be amplified version of this input, right? But instead of this, what is happening, you are seeing whatever at the frequency there is a switching with the nearby some wire is there, then it's going to give you some sort of, so actually they are connected through a parasitic. You can see here there is a frequency signal, here also frequency signal, so both can be connected through some sort of parasitic capacitance, and it depends on how much nearby you are keeping that. Of course you can get rid of it through the technique which we are using, right? But sometimes people are using the normal wire on breadboard, right? So on breadboard itself, it can pick up the frequency signal which is nearby, so we have to get rid of it, right? So what could be the suggestion to get rid of it? There is no unique solution. There are almost like thousands of solutions are available.
You can add some ground wire.
Where?
Like
So I'm saying it is on breadboard. Let's assume that I am not able to do that, but yeah, your solution is correct. You are saying
close to it.
close to this one and close to this one, right? So it's possible. Okay, this is one solution. Any other solution? Going with the topics. Our topic is differential, so let's think something in differential side.
It's one more common source.
One more
Common source.
common source amplifier. Okay, that's okay. One more common source amplifier. Okay, whose input is differentials. That is what you are saying. Then output is actually will look like this one, but at the same frequency, you'll have same phase, and there will be, if you subtract both of them, you're going to have the double of that, and the output signal is clean. There is no single frequency which was at addition and it was acting as common mode, right? So this is you can do. Any other thing? Because what Razavi is saying something else. Third option, maybe, I don't know, I haven't seen this slide from 1 year, so I'll see what he has done. Okay, same. What you are suggesting. Okay, once. But one more solution is possible by the way. I thought in Razavi, we can do this one also. So that will also remove that, right? With the same, because parasitics might be here. That's why I told there are thousands of solutions for such things. But here I took this common mode as a differential. Look at this. This is actually differential. Right? So any of the way you can take it. Okay. So now there is very important thing which is happening most of the time when you are generating VDD. So how to generate VDD, by the way? In your opinion, how this VDD is being fit to the any circuit? You will, if you have to give me VDD of 5 volt, how are you going to give me 5 volt? I have only availability of this plug, so I'm asking what is inside that, how to convert that AC to DC or whatever.
So I will take one line and different points can be connected to.
No, AC. There are 220 volt 50 hertz, right? In India.
Yes, sir.
Outside maybe 110 volt and 60 hertz, right? So, what do you suggest? How to convert that AC to DC?
So they have to rectify.
So when you are doing the rectifier, then what's going to happen?
So we
Are
will
you
have some
going to
ripples.
see
No,
pure
we will have-
VDD?
No, not pure. We will have some ripples. Then it will be filtered with the help of.
But still, it might not be possible to filter everything,
Yes, sir.
right? So that's why this signal is drawn over here like this. So this is the reality. If you are feeding VDD on, on oscilloscope, and you will see that VDD is not exactly stable. If you zoom in and you see that there is some noise, right? Generally, like it's 50 hertz noise. Generally, I'm writing 50 hertz specific to India because it's 50 hertz, which is in a line, right? It might be 60 hertz, which is written in most of the books. They are calling 60 hertz interference, right? Because that frequency only the one where you are converting to AC to DC, right? So this is actually DC. So this is one thing. Other than that, also sometimes if you are like, you can also act as a source of some frequency. You might have some voltage in your body, right? So generally when people are doing such kind of testing on the desk, they connect some ESD strap and they connect it to their body so that they become zero.
Yes, sir.
But you can't do everything which is nearby to zero, right? Let's say some train is going from outside, it has some frequency that will also actually act as possible frequency thing which is connected here, right? So all those things will give you so much kind of problem. And understand, when there is a frequency, it's an AC signal, right? It's not anymore DC. So you can say that VDD is nothing but the pure VDD with some noise. This is also happening at input side also, but I'm saying this is a DC power supply which you are expecting to be only and only AC. Sorry, only and only DC. However, it is acting as AC also. So if it is AC, understand, it is giving its path, and it's give you some different value of signal. Let's see how it goes. Other than that also, if it is, you are expecting this is zero, but zero cannot be available. It will be here and there, right? So that is also some AC and some ground. So this is what I was expecting, 0 volt, and here I was expecting VDD, but both the side there are extra signals are coming. Let's look at one example on that. You have to tell me the exact gain. Okay. Let's go this way. I wanted to give VDD. However, VDD will not be available, purely VDD, but I am going to see something like this, right? Now tell me, what will be the gain if this is M1 and M2? You might be expecting minus GM1 times RO1 in shunt with RO2. But is it that all, or you are going to have something else also?
You get some gain because of this.
So where is that? So tell me the exact gain. So in addition to that, this is acting as a common gate amplifier, right? So in that case, tell me. The gain might be, reducing if both the terms are actually in similar range, right? Because here also some AC signal is there. Same way, this is also not ground. There is also, this might happen that when you are doing all these things, you have to make sure that this amplification should not be so much, right? Anyway, so this will definitely happen. You must have studied somewhere called power supply rejection ratio. This is same PSRR or the power supply rejection ratio, what we are talking about.
So, sir, practically we have to take into consideration or
All
we
this
can remove that?
you have to consideration.
We can
Sometimes
remove
some people's chip is not working. The reason is this one. All these things has to be in accounting of all these things. Right? So power supply rejection ratio, what is that equation? Power supply rejection ratio. Okay. So I'm keeping to you people. What is the PSRR equation? Right? Some differential gain or the gain which we found out because of the power supply fluctuation, that has to be in some ratio. Other thing is GSRR. Same way you are getting the problem because of the power supply, because of the ground supply also you can get similar problem. Right? Because of ground which is fluctuating one, it is also acting as one of the input source, and that's going to add some sort of signal over there, and that's going to create a problem. Right? Note that all these different frequency components are going to be seen at the output, and they are going to create lots of problems. Right? So that can be removed from some differential way also, but these are going to give you PSRR, GSRR. But if when you are taking it in a differential mode, there are possibilities that you can remove them. Right? Anyway, but here you can see still you can't remove exactly what we wanted to remove. It is not getting removed, but it's getting added. But when you are going to take the difference of these two, Vx and Vy, because it was common to both.
Yes, sir.
This was looking, it is common signal to both the side. Both side it's acting as common gate. If same circuit is there here, another balanced network, then it's going to give you same phase output. When you are taking the differential, means it's going to remove that. So in that case, your power supply rejection ratio will be better, and ground supply rejection ratio is also getting better. So you can say that in addition to those two things which we have listed down for differential circuits, two advantages are, Narmit, what are those two advantages?
No even harmonic.
No even harmonics. By the way, there is nothing like no even harmonics. It's ideally.
Reduced it.
So on paper it's zero, but in reality it might have some harmonics.
Reduced common mode noise.
Common mode noise. Okay, that's also gone. And two more things you can write down. It's better PSRR and better GSRR. So both are getting improved. So there are fluctuations coming from power side, coming from ground side, that can be improved by having the differential circuit, right? Okay. So this is also another solution which has been given to us, right? Which I was telling you. Anyway, so now let's go to the circuit. Here you can see that two circuits are not disturbing each other, are actually pseudo differential. Okay, that might not be listed in any book like separately as a pseudo differential, but this is a well-known topic coming from network theory, right? This is same thing, pseudo differential, where you are copying two things And to make it differential, one place if you are giving V in sine wave, other side you are giving exactly 180-degree phase shifted with same amplitude. By the way, here by mistake, if amplitude is A, here also amplitude is A. But here actually it's minus A and here it's plus A. Then it's going to be differential. Of course, V out 1 and V out 2 will also have the nature of having 180-degree phase shifted output, by the way. Right? So when you are going to give such kind of input with some common mode, what do you think? Why we need this V in CM? If we don't give this V in CM, is it okay, or we need V in CM? To bias, right? Just to make sure that your transistor is in the required mode of operation, right? So V in CM is doing that work. And looking into the output side, which is the amplified version with the 180-degree phase shifted. So look at this. So if you are giving V out 2, which is actually negative, here you can see it becomes positive, right? Because the gain is minus GM2 times RO2 in shunt with RD. Same is here, minus GM1 times RO1 in shunt with RD, right? So if everything is identical, M1, M2, all these things are identical, then output should be exactly same, but 180-degree phase shifted to each other, because input was here plus and input was here as minus, so it will become plus and minus, right? So that is what going to happen, right? Now sometimes the problem here is we have not looked at the something called VOCM. If V in CM is there, VOCM is also there. VOCM is the one which is actually changing its location from the V in CM. V in CM and VOCM are not identical. The shift which you are seeing is actually, you can call that one as common mode gain. It gets some common mode gain, right? So that is getting shifted from here. But what it's going to create the problem? It can reach VDD or power supply. The same way, it can, if it is in minus side, it can reach ground. Either of the side, it can go, right? Most of the time, it's going to be higher side only, right? So in that case, what to do? Then you have to declare that one is a large signal. You have to control the input, right? Give small signal so that you can observe the output as it is required. You must have seen this kind of thing in your BJT circuit, right? Or when you have done the experiment in the laboratory, right? That it's getting saturated. So this is happening because of the output common mode or the common mode gain. So this is called common mode gain. So by the way, if you want to see few more things on this, you can check that that it's going to give you more and more harmonics. You can't check the gain exactly what is required, but when it's reaching the higher side, which is VDD, then it's going to give you more harmonics, right? Okay, so now the problem here in this circuit, what was the problem? I want to get rid of this, getting saturation, and I want to do something so that this is not going to give me trouble. Okay, so let's list down the real problem. One problem is known to us. So this is V in and this is V in minus. If I do this one, so can you comment on the current flowing through both the networks? So current depending on what? Let's call it I. This will be definitely minus I. But can you tell me the current depending on what? VGS, right? Or the gate voltage. Whatever you are applying here. So gate voltage is the one which is actually governing parameter for the current. That's not a good idea in my opinion, right? Or you need the common mode which is going to do this one. So what I'm recommending to do, I'm introducing new circuit actually, which is like this, where I'm keeping one current. Let's call that current as 2I. And let's assume that both sides it's identical V. When it's identical V, then this is the same situation which we have talked about, balanced network, both sides are equal, so current flowing through both of them are II, and the current flowing through this one will be 2I, right? So this is what's going to happen. And what it indicates, if both the transistors M1 and M1, which are identical to each other, and RD all are identical to each other, then I need some voltage. So in addition to this, I need some voltage. Let's call this one as V in Cm. Some voltage which is going to make these two transistors just in saturation. However, this gate potential is not governing the current. You see, current is governed by this one because he has to respect KCL, right? If 2I is going from here, there is no matter what voltage you are connecting here. If these two transistors are in saturation, means both the transistors are on, means it's give path from this point to this point, means it's the current flowing through that one is only and only I, right? Because it's a KCL, right? This circuit is actually depending on both sides. So I gave you just half picture, right? I gave you picture when this voltage, let's say something I am giving 0 here, this is also 0 here, at that time this is going to happen. If it is deviating from this situation, means if I am giving here 1 millivolt with some frequency and here minus 1 millivolt, what's going to happen? The current which was here, let's call this one as big current, it's a DC or the common mode current, which is fixed by this guy, right? Or when it's in saturation, the current is actually, let's call this one 2 ICM. But there is another situation when both the voltages are 180 degree phase shifted to each other. Forget about this V and CM at that time. If it is not there, then you are going to see some extra current which might be plus I, sorry, in this case minus I, because the gain is minus, some minus I, and here some plus I. Note that the current, if it is minus, so going from here and it's coming from here, that is not actually going down at all, because this particular potential is 0 when both are 180 degree phase shifted. Means I am taking two things together. One is differential and one is common mode. When both are tied together, the only current which is flowing through both the circuits are exactly identical. When it's a differential, this potential becomes ground and the current is actually not going through this one, it's actually going through other path, right? So this is what happening, right? Or its impedance is very high, right? So this is the theory for origin of the differential circuit, so which is actually going from pseudo differential to differential, where both the circuits are depending on each other. Now you can see the current, if it is flowing through one circuit, then it's going to another circuit, right? Both are actually together. Now you can't say that, unlike the previous one where you are connecting here hard 0 volt and they were not interacting with each other, here that's not happening. Here this is acting as a virtual ground and you are fixing the common mode such that this DC current is going to bias these two transistors using just our given differential amplifier solution. Does it make sense, sir? Right. So here, what are the things happening? Output common mode voltage is getting fixed because of fixed ISS. This is one thing. Transconductance of the amplifier means GM of this circuit varies because of the input common mode voltage. So here GMs are driven by input. Still, it is driven by that, right? Because if GM is also proportional to voltage, right? It's not only current. Input common mode voltage does not determine the current flowing through the input transistors M1 and M2. These two are determined by only and only by ISS, which I fixed it. And ISS determines the output common mode voltage. Right? Here, whatever the voltage will be coming, I am talking about the common mode voltage. Now, common mode is going to be referred as DC. If I am giving DC common mode, preferably it's DC, but sometimes AC can also, bias the circuit. Right? Okay. So let's go as follows. If pseudo differential to differential you have reached, do you have any question on this one? Okay. So if we are going to have such circuit where both the balanced networks are identical to each other and they are connected with a wire, if they are connected with a wire, if both sides I am connecting same voltage, then the current flowing through this one is double, right? If one side it's V in and another side is minus V in, means 180 degree phase shifted. At that time, this is acting as a zero or it's a virtual ground. There is no matter what you are connecting here, forget about that one. It's gone, right? And at that time, you can find out what is happening, and this circuit is actually affecting another one. How you can see that maybe through this plot. If I am giving V in 1 minus V in 2, means V in 1 minus V in 2, which is going from, let's assume that minus VSS to VDD. VSS might be 0 also. In this case, it's 0. If you are doing that, understand it's 180 degree phase shifted. So if one guy is, if here I am applying exactly minus VSS, then other side what it has to be? It should be, it has to be plus VDD. Means VSS is, right? It has to be other side. If you are doing this, then what's going to happen? You are at here, by the way. Right? But if one side becomes, minus VSS and other side VDD, is only possible when you are actually tune it like that. So if one is going 0 and another one is actually going ahead, or sorry, when both are 0, then it's 0 only.
So sir, this is identified practically or theoretically?
No, this is practically. Right? This is the thing we are giving, right? You can design it really. This is possible, no? Is it possible or not? How to get this differential signal in reality, Yugal? It's a good question, but
So sorry sir.
How to get this signal in laboratory? If you go to laboratory, can you give me such kind of signal?
I will take one transistor and another transistor with qualitative integration. So
That
one
will
is-
give delay also. That will give delay.
So this I go. Right.
No, I'm saying
Try.
if you go to, let's say, IIT Mandi's laboratory, those who have visited IIT Mandi's laboratory or your own laboratory where you did this experiment, how do you get the differential signal? Understand? You don't have to create new circuit. Do we have option available in the oscilloscope? Function generator. Those function generator which has such kind of option, those are very expensive, by the way. Okay, those kind of function generators are not in our UG laboratory, right?
I have worked on one function generator where we had when the two channels could be linked together and then we would
Through the backside. At the back side, you have to convert it to 180 degree phase shifter, or they have to be in sync. Then it's possible.
Sync option was also there and that other option also.
But all the function generator does not have that option, right? What we kept it for UG laboratory, it does not have that one, or control laboratory, embedded system laboratory, we do not have that, right? So how to, okay, let's go this way. I'm going to buy very simple one. Let's say I have simple one. Now can you give me the internal circuit available in function generator, which is going to give me this one? There are many electrical, right? How many electrical? BTech electrical, many are there. No? Those who have done BTech electrical. How to get this one? Sine wave with 180 degree phase shift. Right? It's not an inverter. Inverter will give you the large scale signal, right? Communication can also give, because it's very popular in let's go this way rather than, right? It's a center tab, right? If you give here plus V, another is 0, other side plus V, other side minus V, but half amplitude, right? This is possible, right? So it will not give delay, both are exactly identical. By the way, this particular circuit, electrical people call it transformer, right? But we don't call it transformer. This is very popular name is balloon. Balloon. Okay. The spelling is correct or no? Right? So this is very popular. RF engineers or communication or VLSA engineers, they are using this. They are making that actually. Right? You have to make your own transformer or the balloons, which is going to give you the differential signal, right? Anyway, so if you are doing this, if both are 180 degree phase shifted to each other, as you are going, look at this, it's keep on, you know, increasing. One side it's increasing, other side it's decreasing, so on and so forth. At this place it's become, you know, 0. This place, right? So if this is, let's say, VSS, and if this is VDD, right? So if both are starting from 0, no problem. Right? In between, accordingly, it's going to be increasing to, like, going from minus VSS to VDD. If you are looking into only amplitude, so mod of Vn minus V2 is going to give you this one. And if you look at the output, what's going to happen? If you look at the Vout1, I can write down as IDRD1, right? Mine, okay. So I have to start from there. So VDD minus IDRD1, right? But ID is ISS by D, right? So it is okay. It is written over here. So if you are going at the, you know, place where one of the transistor is on. Look, when you're starting from one side, one of the transistor is getting on and another is getting off, right? So two sides are going to be there where one of the transistor is getting on and it's dominating its amplitude. So it's going to be like this. And same way, other side Vout1 is going like this with some common mode. So it's going to be touched somewhere with some common mode. If you take the differential, common mode noise is gone and this is going to be double. Look at, right? This particular swing might be double if you take the differential of that. Right? So this is what happening. Maybe such things you will learn it when you are going to, you know, do the experiment. Anyway, so differential is already known to us. What is differential? So V in 1, V in 2 are 180 degree phase shifted, but I am drawing the same thing again like this. I can call V in 1, V in 2, then other side I am keeping this as 0 quantity only. Look at this, there is 0 only, right? Here this was becoming V in 1 by 2, and this was, sorry, V in 1, and other side this was V in 2. But what I am doing, V in 1 plus, so half of quantity, this is for my just understanding, I did that. If I do that, then what's going to happen? There are two quantities coming out. One where two signals are going to be subtracted, like V in 1 minus V in 2 divided by 2. Here V in 2 minus V in 1 divided by 2, right? And another quantity which is coming here is V in 1 plus V in 2 by 2. And here also V in 1 plus V in 2 divided by 2. Red color quantity are common to both. These two are going to act as common mode, and both differential, which are 180 degree phase shifted to each other, they are acting as a differential quantities. So you can draw it simple way like this. Okay, so this is common mode, this is differential, right? Okay. Let's go to little bit on common mode range. So input common mode range is the one. So there are two kinds of CMR. One is called input common mode range and one is called output common mode range. So input common mode is the one where you are giving the minimum input DC level which is not going to saturate the output. Saturating the output means you are not reaching VDD or not going ground, right? So this is what I am talking about, the saturation means. So input which is not going to saturate. Same way, output common mode range is the one where output is not getting saturated, right? So this is what I need to find out. With example you will understand what I mean to say. So these are the two things, right? Okay. So we'll again revisit that, but before that let's learn to make differential gain, because we have to have following things for any ideal op-amp or amplifier, where we need to have the small signal AC gain which is actually differential by nature. If you remember, ADIF and common mode gain which has to be as low as 0, there should not be any fluctuation in terms of input and output levels, and my main agenda is to make this common mode rejection ratio as high as possible. This is only possible when ACM goes to 0 and ADIF goes to infinity. So I need to find out CMR. That is what I want to find out. Okay. So look at this circuit, where this is exactly like the way we have started with. One side is blue side, one side is green side. Both are exactly identical, connected through a wire whose this point Vx becomes 0 when V in and V into are differential or 180 degree phase shifted to each other. However, in the case of both are same, this is not going to be the true, but both sides the current are exactly identical, or ISS by 2, right? So in that case, this particular network is going to be there. ISS will be there. Means you have to find out the impedance or whatever is there. It's going to affect both the circuits. But in other side, this was actually ground. Okay. So that is known to us. Now another thing is what I am making the assumption. This might not be true all the time, but on paper, let's go assume that RD1, RD2 are exactly equal to RD, GM1, GM2 are exactly equal to GM. Or if there is any body effect, then also GMB1 is equal to GMBS1, GMBS2, and that's equal to GMBS. If there are output channel and modulation resistances, then also they are identical to each other. So everything is identical. That is what we assume at the beginning, if you remember. So balanced networks are identical to each other. Then what I can do, if I am applying the differential input and I am interested in finding out the differential gain. So there are two gains are there. One is called differential gain and another is common mode gain. I'm interested in finding out the common mode rejection ratio, which is actually A diff by ACM, right? So if this is the case, then with the first quantity which I want to find out, it has differential gain. When I'm doing this particular node goes to 0, right? It's virtual ground. If it is virtual ground, I can do this one, right? One of them, let's keep it one side. Find out what is the gain one side. Minus GM1 parallel RD. Let's again other side. What's going to happen? By the way, GM1, GM2, RO1, RO2 are exactly identical. You can replace them by the way later on. So if you are doing that, by the way, V in 1, V in 2. Okay, this is another example. So if that is the case, can you take the subtraction of addition of both the quantity and let me know what is V out by V in? 1 I got V out 1, 1 I got V out 2. V out 1 by V in 1, V out 2 by V in 2, I got this quantity. Let's call this one as GM RO shunt with RD. Here also called minus GM RO in shunt with RD. Can you take both the addition because subtraction? V out 1 minus V out 2 divided by V at 1 minus V in 2 is going to be equal to, so I can write this one, multiply by V in 2 multiply by V in 1, right? If I subtract both the quantities, V out 1 minus V out 2, what I'm going to see? GM times RO in shunt with RD, right? Same gain. The only thing which is changing is O here, right? So gain remains same, right? So it's same thing. So one side if you can find out, so that's why this concept is known as the half circuit concept. Half side you just find out whatever is coming with considering wherever there is a virtual ground, then you are with the differential gain. This is called differential gain, right? Right? Can I take 5 minutes more so that you can solve the common mode gain also? So if now you learn it, right? Now I'm asking you people, if I'm giving both the side same voltage V in, note that all these assumptions remain true. The only thing is I am giving both sides V in, means like this. Like this. Both are same, then it's common mode, right? If both are same, then what's going to happen? I can draw the circuit. First of all, I'm replacing here that current which is here, whose output impedance is something RSS maybe or RO, right? Whatever the is there, I'm writing it RSS. Okay, just for my understanding. If I am doing this, I can draw its circuit like this because it's common mode, so both sides it's tied together. So I can do this one, right? So this is GM1, GM2, both are identical by the way, as I have written. Two GMs are in parallel. Look at this. Two GMs are in parallel. So what I can comment on that? 1 by GM1, 1 by GM1. So what's going to happen? 1 by GM1 plus GM2. So that's going to give me 1 by, both are same, then it's 1 by 2 GM. And in this case, it's RD by 2. I can draw this network again. This is 2 GM, this is RD by 2, and there is extra resistance is already there, which is coming from the current, which is RSS. So this is V in, and if this is V out. Now can you tell me what is the gain? What is the gain? Okay, so I'm keeping to you people. Okay, this is a source degeneration to find out, and that becomes the common mode gain. and CMRR is equal to, for this particular circuit, whatever differential gain was there, divided with common mode, that's going to give you CMRR. Maybe further we will practice once I'll return back, right? Something like that.